Good morning, this is David Johnson from High-Tech Global Solutions. Today I'd like to discuss a topic that's something you need to look at before you start doing your analysis in any detail. What I'd like to look at today is backdoor data. So what I suggest is you look at these parameters very early on, because you need to set these parameters up for your analysis. Plus, my recommendation is you set these parameters up and then put them into your template so that when you boot up Hypersizer, you have the correct defaults. So as you can see here, we have a many number of variables. We have a default value, which is the template value, and a project value. So if I put a value in here for a project, it would only be applicable for this particular one project. If I open this project above, the parameters would again default to the default value. So if we look down this list, bonded joints, it's my view that bonded joints is still kind of a beta feature in Hypersizer. So I kind of blow past those and I go down to bolted joints. Very important parameter here. If you're optimizing some thicknesses with countersunk fasteners, the normal ratio is 80% at most aerospace companies. You may wish to put in a different value. Some companies use 70% for primary structures. So in here, you can simply type in any number you wish, but for today we type in 0.7. The local buckling coefficients, they're probably all pretty much good to go. Statistical optimization, you may wish to change some of this, but it's kind of a secondary consideration. But two parameters here that stand out for composite analysis. One that's very common is that, well, unfortunately Nastran is not too smart, so that when we put the modulus in for the shell elements, we can only put in one modulus. We can't put in a tension modulus, we can't put in a compression modulus. So most aerospace companies use the average modulus in the FEM. Now that means that often we calculate the allowables based on an average modulus, which is kind of a bogus number, but it all works out in the end. It gives the correct, it correlates better with the test results. What we do here most often is we put in a true. The default is false, so I suggest you review your analysis methods and put in the appropriate parameter here. My recommendation is to use the average modulus for the FEM and the analysis. The other item down here is crippling using damage tolerance allowables. I've had quite a bit of experience with this, and the default is true, but the problem is that gives a very conservative crippling allowable. And perhaps from a global perspective, putting in false will get you to correlate with the test much better. Of course, there's some certification issues with doing the detail analysis, but that's for you guys to figure out. But all I'm saying is the false will probably give you a better correlation with your test. So we have a whole bunch of other variables down here. We have the component modification, which is the ABD terms, probably all okay. Then we have HyperFemGen. HyperFemGen is simply a package to export finite element models from your optimization process. There are no menus for this, so most of the stuff is done behind the scenes, and this is where you set all your parameters for HyperFemGen. This is a very specialist topic, so I'm not going to go into detail here, but I'm just going to give you advice that, hey, this is where you go look to try and find those variables to set up the models, to export the models. Next is geometry checks. Now, geometry checks is very important when doing composite analysis. I mean, for instance, if I want to attach with fasteners a composite angle to a skin, I need to be very careful of how wide the flange is and what edge distances I have. So lots of parameters here that you need to go look up in the help menu and figure out if these parameters are correct for you. These are correct defaults. Mostly they're pretty good, but you may wish to change some of those. Connection T-joint, don't really do much with that. Panel buckling, probably not much to do there. Buckling coefficients, obviously these are what Craig uses in his standard analysis. If you have test data and you wish to use something different to correlate your test better with this buckling analysis, you may wish to change some of these parameters. Then we have discrete stiffener modeling, probably wouldn't change too much there, and we have load case filtering. And probably again the defaults are pretty good. In summary, modify your default backdoor settings before you do your analysis, and then save those settings to the Hypersizer template. Thank you very much, and thanks for your time.